more conversions. This time, instead of coordinates, we're doing equation conversions. We're converting equations from rectangular form to polar form specifically. And the good news is I think going from rectangular to polar form is the easier one, not because either is very difficult, but because at least with rectangular, there really are very few decisions that you have to make. All you're going to do is stuff these equations into what you're given. So everywhere you see an x, you replace it with r cosine. Everywhere you see a y, you replace it with r sine. And, just follow the algebra wherever it goes, you're in the right direction. So let's see what we got here. X equals 4. Well, that doesn't seem too bad. So we're going to replace x with r cosine. I get r cosine theta equals 4. See, it's just a straight swap. And now, since I want the equation to be r equals, right? That's what solve for r means. I'm just going to divide each side by cosine. So r equals 4 divided by cosine theta. There we go. If you want, you could write it slightly differently. You could say 4 secant theta, but those are the same thing, and either one works. Now, if you look at this next one, this is also pretty easy. Okay, I'm seeing x squared plus y squared. I think I can use that. So I replace x squared plus y squared with r squared. R squared equals 3. Okay, well, I just need r, so I'm going to square root each side. I get r equals square root of 3. Now, someone's probably thinking, well, wait a minute. You're making a square root happen there, so this needs to be a plus or minus square root 3. Okay, fine. Either one works. They are equivalent equations. Check this out. If I draw a grid right here, badly, but if I draw a grid and I say, what's r equal 3 look like? Well, that's just a circle. It's all angles where r equals 3. Well, what does r equal negative 3 look like? It's just a negative circle. Maybe you draw it in a clockwise direction instead of counterclockwise, but they are the exact same thing. So in this case, it doesn't really matter too much whether you put radical 3 or negative radical 3 as your answer. They will both be marked right. Okay, so now we're getting a little more involved. The method will be exactly the same. You're still going to put equations in, but I would suggest when you see parentheses like this, maybe go ahead and do the algebra first before we make substitutions. And so here's what I mean. I'm going to say, oh, this is just x squared plus y squared plus 4y plus 4. Okay, right? I expanded out that y plus 2 squared thing. Don't forget about the cross term right here, that 4y. That's important. And on the right, I have equals 4. Okay, well, I can simplify this some more. I can say, oh, subtract 4 from each side. So let's turn that into x squared plus y squared plus 4y equals 0. That seems nice. And now it is time to make some of those polar equation conversion substitutions. So I'm going to take that x squared plus y squared and replace that with r squared. And I'm going to take this 4y and say, oh, that's just 4r sine theta. Okay. Now this is a polar equation in every way. It's r's and thetas. The only thing missing is I need to get r on one side by 12. So what do we do here? This, if you answer factoring every time I ever ask you a question, you'll be right a decent amount of time. We're going to factor out an r. That's our GCF. So we have r, and we have r plus 4 sine theta equals 0. Okay, what do we do when we're factoring? We set each parentheses equal to 0. Now you'll see here, it says hint, r equals 0 is a degenerate equation. This is what we're talking about. We don't worry about r equals 0. Okay, that's nope. That's the equivalent of DNE, right? It's just a point at the origin. It doesn't really mean very much, and it's degenerate, so we're going to ignore that one. Here's the equation we like right here. I say, oh, r plus 4 sine theta equals 0. Well, that means r equals negative 4 sine theta. Okay? So that would be our answer. That's what we put in here. As an interesting aside, remember that part? You may feel uncomfortable with me saying, don't worry about that r equals 0 thing. It's not important. Well, think about this. If you were to plot what r equals negative 4 sine theta looks like, and I know we haven't done much of this yet, But let's imagine we plug in, I don't know, theta equals 0. Okay, at theta equals 0, what is r? Well, let's find it out. When theta equals 0, this becomes negative 4 times the sine of 0. Well, sine of 0 is 0, so we get r equals 0. So see, we didn't lose r equals 0 at all. It was just written in a different form. Weird things like this sometimes happen with polar equations. Okay, so there will be times when you often have to ignore that r equals 0. Don't feel bad. Okay, moving on. Now with this one, see, I don't have a whole lot of algebra to sort out. This is really, it's not going to get a whole lot simpler than what we have here. So I'm just going to go straight for the substitutions. I'm going to say r cosine theta equals 2r sine theta minus 4. And I want r by itself on one side. So let's just get going with that. I'm going to say, okay, well, this is r cosine theta minus 2r sine theta equals negative 4. I'm going to factor out a GCF. This becomes r times cosine theta minus 2 sine theta equals negative 4. Notice this is not really a factoring problem. It doesn't feel like a trinomial thing. I did factor out a GCF, but I can solve this very quickly by just dividing the left side by this whole thing, this parentheses. So this becomes r equals negative 4 divided by cosine theta minus 2 sine theta. I know it's not the prettiest thing, but that is our answer right there. Okay. So next up, what do we have? Convert the equation, blah, blah, blah. Oh, we've got a little warning here. Degenerate equation. You can take that as a hint that there's going to be factoring involved, if you like. So let's see what we can do here. And again, I'm going to play with some algebra first. I'm going to rewrite this. I'm going to say, hey, I like x squareds and y squareds, but let's get those guys together. In fact, let's get everything on one side. This becomes x squared plus y squared minus 4x minus 2y equals 0. Because I have a feeling I'm going to need an equals 0 over there when I start my factoring. So x squared plus y squared is easy. That's just r squared. Minus 4, what's x? Remember, r cosine theta. What's y? That's r sine theta equals 0. So now we have some factoring to do. And I would remember, stick with that GCF. GCFs really are very, very useful. Factor out an r, and what do I get left? R minus 4 cosine theta minus 2 sine theta. Well, this looks ugly. We've got r equals 0 over here. Remember, we kind of ignore that. It's degenerate. And then in this part right here, we say, okay, that equals 0, which means r equals 4 cosine theta plus 2 sine theta. Once you add those to the other side, you're right. We blinked and we're done. So that's it. The theme here, if you've picked up on it by now, is just apply these equations and let the dust settle as it may.